Okay, nuclear note page 234, example 2. So let's look at another example of a half-life problem. So our example reads, what is the half-life? So what is the half-life? So we need to find what is represented by capital T of a radioactive sample that decayed from 200 grams, which would be our original mass or starting mass, to 25 grams, which would be our ending or final mass, in 90.8 years. And so this would be our total time. Okay? So just remember, with these charts, the first line in the chart is always our position of starting. So that means no time has passed, no half-life cycles have occurred, and we still have our total original mass of 200 grams. Now, in example 1, we were given the total time and the half-life rate, but in this problem we're given the original mass and the ending mass, so that's the information that we should start with. So I'm going to work my way down the chart from 200 grams to 25 grams. So 200 grams, no cycles have passed. When the first cycle passes, that means I have 100 grams remaining from the original 200. When a second cycle passes, that means the 100 grams is now cut in half down to 50 grams. And a third cycle occurs. The 50 grams is now cut down to the 25 grams. And 25 grams is the provided ending or final mass. So that's the final mass. So for this problem, I don't need to cut the mass in half any further. So take a look. To get for my sample to decay from 200 grams down to 25 grams, it required a total of 3 cycles. And to go from 0 cycles to 3 cycles, this represents the total time, which in our problem was the 90.8. So if I want to know the half-life of this problem, okay, I can take my total time of 90.8 years that have passed, and I can divide it by the number of cycles or half-life periods that have passed. So 90.8 equals a half-life cycle of 30.27, because I think it's repeating 6. So that it requires around 30.27 years per half-life cycle or half-life to happen.